Spinosaurus is easily one of the most talked about dinosaurs ever discovered. Despite the fact that Tyrannosaurus has a much better fossil record and a much better academic paper record, and despite the fact that Tyrannosaurus has been the big bad dinosaur in basically every form of paleo media ever made, Spinosaurus is somehow outpacing it in popularity when it comes to paleontological discussions online. It thankfully doesn't have as much baggage as Tyrannosaurus, but its unique anatomy and mysterious nature makes it far more enticing to plenty of us. Thing is, we still don't know exactly what Spinosaurus looks like, nor whether or not we have more than one type of animal on our hands. Spinosaurus, a theropod dinosaur that was first discovered in Egypt and subsequently described in 1915, was always acknowledged to be one of a kind due to its distinctive sail. The 1930s saw the description of additional specimens that were quite similar to those already known, the most complete of which was given the name Spinosaurus B. Spinosaurus aegyptiacus. Let's begin with what everyone is already familiar with. Spinosaurus aegyptiacus is the scientific designation given specifically and most validly to the first published specimen of Ernst Stromer's collections in 1915. The holotype specimen was described as having a dentition that was distinct from that of other theropods, as well as a spine that was unlike that of any other tetrapod animal. Spinosauridae would be the name of the brand new family that would be established for the purpose of accommodating this taxon. It would be many decades before even more animals similar to this one were found again, and it would be much longer before it was realized that they belonged to the same family. Before any more study on this renowned specimen could be published, it was destroyed in an airstrike on Munich during World War II. This would be the end of the line for this specimen. Spinosaurus B. The Bahariya Formation would continue to provide more Spinosaur fossils during subsequent exploration efforts. Although unfigured specimens have descriptions, they do not have any photographs, since in most cases, they were not articulated or connected with other specimens. The Spinosaurus B case is an unusual one. Stromer did not feel that the specimen represented a single individual, despite the possibility that the material was loosely associated with one another. This was due to the size difference that existed between the bones of the limbs and the vertebrae. In particular, the limbs were called into question, but the vertebrae, in particular the dorsal spine, were dead giveaways to this animal's relation to Spinosaurus aegyptiacus. This is despite the fact that a few of the vertebrae differed from the original specimen in size and diagnosis. Notably, he declined to label it as a new species, arguing in the 1934 paper that he strongly disagreed with the practice of designating new species based on fragmented or isolated specimens, even if they were unique. This refusal to designate it as a new species is notable, as plenty of researchers before and during his time were quite gung-ho about naming things. These specimens were kept at a museum in Munich, Germany. World War II would shortly break out, and all Spinosaurus specimens, including the holotype of Spinosaurus, were destroyed in a bombing strike. It would be decades before any additional creatures like them were discovered. Spinosaur bones from Morocco, previously discovered exclusively in the form of teeth, were eventually published in 1996. SIGIL MASSASAURUS and a new Spinosaurus species, Spinosaurus MAROCCANUS, were created. Each was linked to isolated remains and corresponded to the missing Egyptian specimens. Spinosaurus MAROCCANUS. Dale Russell published a study in 1996 on newly found isolated Moroccan dinosaur material. Spinosaurus MAROCCANUS was among them, the first North African spinosaurine named since Stromer's initial specimens. Until then, there was insufficient material to qualify. Spinosaurus MAROCCANUS was a cervical or neck vertebra, similar to Spinosaurus aegyptiacus, but with differing dimensions. Other comparable cervical vertebrae were given to the taxon as well, and although they varied in elements such as neural spine height, this may be explained by the vertebrae occupying various places along the neck. Furthermore, isolated lower jaw fragments were attributed to this taxon since they were almost similar to those of the Spinosaurus aegyptiacus holotype, although smaller in size, which could easily be attributable to size variation. Given the restricted components, Spinosaurus MAROCCANUS was thought to have a longer neck. SIGIL MASSASAURUS BREVICOLLIS. Dale Russell described not just a new species, but also a new family of enigmatic theropods in his 1996 paper on Moroccan dinosaurs. The genus SIGIL MASSASAURUS BREVICOLLIS was described on what were previously assumed to be Spinosaurus neck vertebrae that were broader than they were long, and the then new family SIGIL MASSASAURIdae was made to house it. Close parallels with Stromer's Spinosaurus B were recognized since the missing Egyptian specimen was quite similar in general size and morphology to the Moroccan species, and it was proposed to likely represent a SIGIL MASSASAURID as well. Based on the referral, isolated tail vertebrae from Morocco were also attributed to SIGIL MASSASAURUS, with anatomy resembling the lost species but lacking the bigger tail vertebral spines that Spinosaurus B seemed to have. Furthermore, a centrum, or the body of a vertebra, was assigned to the genus but not the type species, despite its resemblance to other specimens but a lack of critical information for a definitive attribution to any one species. North African Spinosaur research would continue over the following several decades, but it came to a climax in 2014 when a discovery of a partial skeleton of Spinosaurus represented by fragments of most of the body was reported. Furthermore, it was claimed that both Spinosaurus MAROCCANUS and SIGIL MASSASAURUS were additional Spinosaurus aegyptiacus specimens. For most, this is where the narrative stops, only to be taken up again in 2020 with the publication of this same specimen's tail. This, however, is not the case. Several publications on the classification of these enigmatic theropods were released in the 2010s. Publications would support the presence of more than one chem Spinosaur before being buried back into Spinosaurus, only to be divided again before finally merging. The most recent, a 2020 study by Smith and colleagues, included not just all North African Spinosaurian material into Spinosaurus aegyptiacus, but also the Brazilian Oxalaia, represented by the tip of a snout. So far, this is the conclusion of the broadly accepted narrative. Here is a quick timeline of North African Spinosaurian taxonomy. Stromer, 1915, the original description of Spinosaurus. It represented a new and unique kind of theropod. Stromer, 1934, description of additional Egyptian Spinosaurids including Spinosaurus B. Spinosaurus B is noted to be different from the type species, but no new species is named for it. Russell, 1996, description of Spinosaurus MAROCCANUS and SIGIL MASSASAURUS, the latter of which is given to its own family, SIGIL MASSASAURIdae. Spinosaurus B is implied to possibly be a SIGIL MASSASAURID. McFeeters and others, 2013, re-evaluation of SIGIL MASSASAURUS. In the last decade, the taxon was bounced between belonging to a Carcharodontosaur ornithopod or basal titanuran theropod. This study concludes SIGIL MASSASAURUS as a valid theropod taxon. Ibrahim and others, 2014, A. Announcement of the Spinosaurus neotype. All North African Spinosaurians are stated to be Spinosaurus aegyptiacus, though no justification given. Alain, 2014, in Press. Abstract on Ichthyovenators cervical series. Holotype of SIGIL MASSASAURUS, a dorsal, is mostly identical to Ichthyovenator's first dorsal. The former is suggested to be dubious, possibly synonymous with Spinosaurus. Evers et al., 2015. SIGIL MASSASAURUS reappraisal. Spinosaurus MAROCCANUS lumped into SIGIL MASSASAURUS BREVICOLLIS. SIGIL MASSASAURUS BREVICOLLIS seen as distinct as is Spinosaurus B. The proposed neotype of Spinosaurus is suggested to represent a different species than the holotype. Hendricks and others, 2016. Chem Quadrate paper. Two morphs from the Chem are recovered, each referred to Spinosaurus and SIGIL MASSASAURUS respectively, though referrals based only on size. Arden and others, 2018. Chem frontal paper. 2 morphs from the Chem are recovered again, each referred to Spinosaurus and SIGIL MASSASAURUS respectively, based on the size of each again. Smith and others, 2020. North African Spinosaurine reappraisal places all North African Spinosaurs, including SIGIL MASSASAURUS and Spinosaurus B, and even Brazil's Oxalaia, into Spinosaurus aegyptiacus. Reviews each anatomical morph. Barker and others, 2021. Ceratoseucopsini description codes all North African Spinosaurs as distinct. SIGIL MASSASAURUS not always recovered as sister to Spinosaurus. Shares this with Malafia and others, 2019. The Valibona venatrix description. McFeeters, 2021. Description of a third Chem cervical morphotype. Differs from both Spinosaurus and SIGIL MASSASAURUS morph cervicals in discrete but potentially important ways. Taxonomy left as an open book. As the default hypothesis, we should reject the idea that all these taxa constitute the type species of Spinosaurus, and just briefly discuss each major taxon. To begin with, the real Spinosaurus aegyptiacus is only known from Egypt. The neotype, discovered in Morocco, lacks adequate data to be assigned to the type species, and it may be argued that, for the time being, a different denomination within the genus should be used for the species. Despite superficial similarities, further information is required to determine the link between the holotype and suggested neotype of Spinosaurus aegyptiacus. Even for a more liberal approach considered for the nature of the field, the specimen FSACKK11888 presently fails to meet the requirements required to establish a neotype stated by the ICZN. Most significantly, it is a third of a continent's distance away, and although this may be due to a larger in-life range, it still argues against neotype certification. Furthermore, the specimen lacks adequate osteology or study of its bones directly. There isn't a huge treatise on the specimen that describes each and every bone in excruciating detail. This will of course change with time, but direct comparison to the holotype is difficult, and any deviations should be viewed as having a basic degree of taxonomic significance, rather than being dismissed as individual variation. You could argue this if the Spinosaurus sample size was as large as Tyrannosaurus. To some extent, this taxonomy is also exaggerated. They constantly clade together, and at first appearance seem to be quite closely related. They may be sister species. As a result, the suggested neotype should be referred to as Spinosaurus sp or Spinosaurus cf aegyptiacus. Only more material from Egypt, not Morocco, can glean more from the holotype species and more definitively clarify the taxonomic connections of these big creatures. SP and CF are taxonomy terms that help clarify the ambiguousness of a species or genus-level distinction for a given specimen. Spinosaurus taxonomy problems go beyond the suggested neotype. As previously noted, whether or not SIGIL MASSASAURUS represents Spinosaurus has been debated for years. Oxalaia has lately been proposed to represent both the genus and the species. On SIGIL MASSASAURUS BREVICOLLIS. The notorious Chem group's second Spinosaur, taxonomically SIGIL MASSASAURUS has a far longer and more convoluted history than the Moroccan Spinosaurus. Evers and others 2015 provide a comprehensive analysis of the species, as well as new specimens being assigned to the taxon based on anatomy found on both the spine and the underside of the central body of the vertebra. SIGIL MASSASAURUS illustrates an intriguing discussion that encompasses all Spinosaurine material from the Chem group, that numerous elements do not fit neatly into a single taxon. Those who think that SIGIL MASSASAURUS is synonymous with Spinosaurus simply feel this is a variant, despite the fact that not all of the material fits neatly under Spinosaurus. However, if it is separate, it opens the floodgates as to which of the material, all of which overlaps, belongs to which taxon. Unfortunately, this has had the unintended consequence of numerous materials referring to SIGIL MASSASAURUS without a genuine foundation. SIGIL MASSASAURUS skull. This skull is a privately owned composite located in Japan, though many casts exist. It is often cited as a possible SIGIL skull, but it is heavily reconstructed and should not be seen as such. Beneath the layers of plaster, however, there must be something real, but as to what is currently unknown. On Ocellaia quilombensis. Ocellaia quilombensis is a very fascinating theropod, but for all the wrong reasons. The sole material known from this Spinosaur, described in 2011 from Brazil's Alcantara Formation, is the tip of the snout. The taxon was also named for a portion of the maxilla, however, it was unrelated to the original specimen. Furthermore, similar to the North African Spinosaurine difficulties, isolated vertebrae have been ascribed to this species with no genuine explanation. For many years, it was listed as one of Brazil's biggest known theropods. While this is still kind of correct, despite the fragmented condition of the material, its connection to Spinosaurus would emerge in Smith and others' 2020 when Ocellaia was assigned to not just the genus, but also the species Spinosaurus aegyptiacus. This is problematic for a number of reasons. While a 2017 amended diagnostic called into doubt aspects of the initial diagnosis, the 2020 research would dampen them even further. Many spinosaurids share tooth features, and the shape of the premaxilla bones at the tip of the snoot is comparable to that of Spinosaurus as well as other spinosaurids. Despite the fact that these characteristics are shared by many other taxa, it is nonetheless classified as Spinosaurus aegyptiacus. It is proposed here, although unofficially, that Ocellaia should be considered Spinosauridae indeterminate, and this overlooks the fact that the rostrum often used to represent Spinosaurus has also not been conclusively established to belong to the genus. This is bolstered by the knowledge of multiple types of Spinosaur material from North Africa, representing sections of the head and body. North African Spinosaur morphs. Dorsal spine morphs. Despite possibly being the most taxonomically important, this is the most tenuous morph. The Chemchem group is notable for a variety of spines, but the main difficulty with them is that many of them are privately owned or otherwise undocumented. Regardless, the position stated here is that, if genuine, the spines have morphologies that are much too atypical to belong to Spinosaurus aegyptiacus. Other Spinosaurines indicate that the form of spines may vary widely along the back, but it is argued here that the spines of a single individual, although variable in shape and outline, are not significantly different in general morphology. Furthermore, if these enormous features are purely for show, they should be considered taxonomically important, as they are in a variety of ornithischians and hoofed mammals. Frontal morphs. Arden et al. 2019 report spinosaurid frontals from the Chemchem that are quite distinct from one another. The overall location of the orbit and, more crucially, the presence or absence of a long sagittal crest distinguishes them. Jaw morphs. Spinosaur jaw material from the rostrum and dentary has been discovered throughout the years. Individual variation has been used to explain the discrepancies. However, the differences are rather large. The fact that they mirror changes throughout the body should tell you something. Cervical morphs. Cervical variants have been explored in the literature for some years, including those like the neotype, those resembling SIGIL MASSASAURUS, and a third that does not fit well into either. Some think it is due to variety and ontogeny, while others say it is proof for more than one Moroccan Spinosaur. Quadrate morphs. The quadrate morph is the most tentative. According to Hendricks et al. 2016, each quadrate morph is allocated to Spinosaurus or SIGIL MASSASAURUS based only on size. This is a common pattern among many, but not all, of the morphs. In arguments for synonymy between all of these materials with Spinosaurus aegyptiacus, individual variation, antiphonemy, or how a fossil is warped through time is often used to explain differences between all respective parts of the body. While dinosaur variation may be considerable, the degree of variation can only be determined with enough well-represented examples, such as Tyrannosaurus. With just one articulated specimen of Spinosaurus, claiming variation without a strong handle on it is difficult. On the individual variation of Spinosaurus, it's difficult to explain the discrepancies in distinct Spinosaurus specimens as a result of individual variation when there's no agreement on what that variation even looked like. Dinosaurs, like many other tetrapods, exhibit a lot of variation between individuals, but this variation can only be accurately assessed and evaluated with a large sample size and a comprehensive overview of the material. Tyrannosaurus rex, for example, has previously been thought to have morphs or perhaps numerous species based on surface distinctions, but this is just variation. T-Rex neck vertebrae, for example, differ substantially, but only in their robustness. Furthermore, the existence of rugosities underneath their neck vertebrae varies, but in response to ontogeny. This is only known for a rather large sample size in the enormous Lancian theropod. An adequate sample size in African Spinosaurians is severely deficient, particularly given that just one partly articulated specimen is now known. These challenges are exacerbated by the fact that many, if not most, of the specimens being grouped have little to no overlap. Spinosaurus, regardless of type, lacks a rostrum, the central bodies of most of the front-back vertebrae, most neck vertebrae, and most of the forelimbs. However, material from these areas of the body is attributed to Spinosaurus based only on provenance. Additional material, differing in discrete but detectable ways, is then sent to the species based on the original referral, with any variations being waved away with varied degrees of confidence as individual variation. With all of this in mind, is individual variation a valid observation or a convenient excuse for a lack of resolve and comprehension in the variety and distinctions of these specimens, taxonomic or otherwise? So where does this leave us? Finally, only the original species may be claimed as Spinosaurus aegyptiacus. The neotype is closely related, but there isn't nearly enough evidence to confidently attribute most material to any one species. In any case, there is a very good chance that the variety of derived Spinosaurians in North Africa and Gondwana is more than is often assumed. After all, the presence of numerous species of closely related forms in close proximity is not unusual in most assemblages. Evidence of more than one Spinosaur in any given Cretaceous ecosystem has been consistently found over the last few years, with the most recent example being the Ceratopsuchops Rhaperovenator baryonyx grouping. The research and overview of Spinosaurus and Spinosaurinae is still lacking, yet there is no scarcity of information. More research is required to properly understand the interrelationships of these big piscivorous dinosaurs, but contrary to popular belief, this is not an unattainable or distant aim. Time will give us a greater knowledge of these famous, yet sadly misunderstood, sailback dinosaurs. The script for this video is based on a Twitter thread by the paleo artist Lancian Idolatry, link to his account and the thread he made in the description and comment section below. For more interesting stories about nature, the history of life, or what goes bump in the night, subscribe, like this video, drop a comment in the comment section below, and hit the bell icon to stay in the know with everything Edge. Thanks for watching. Special thanks to Elephant Tier patrons Abby Smith, Arda Bayer, Biotiverse, Cherry Shaw, Chris Frampton, Christoph Hubbinger, Dinosaur, Ed Peretz, Isaiah Garza, Jax the Hacks, Natty Cat, PA Brew News, Ray, Rudy Redgrave, Smiling Walrus, Staniforth Hopkins, Steve Bradshaw, Thea Svensson, and Extraterrestrial, as well as my toppest tier Tyrannosaurus patrons, Admin, Antron, Aphid Kirby, Cyber, Dana Manchester, Danny Van Heck, Henry Brennan, Iberospinus, Iron Bladesman, Joshua Mana, Panic, Radio 404, Robert Kessler, Ruben Zachariah, Swaffles is Weird, Teeny Dragator, and The Dogman.